Welcome back, guys. In this video, we'll be just performing the DHCP protocol. So, DHCP is known as Dynamic Host Configuration Protocol, and it's a network protocol that automates the assignment of the IP address and also to the other configuration settings to the devices in a network, and it ensures the efficient and the seamless connection and the communication without the manual interference. Okay, so now we'll just perform DHCP in our laptop. So let's start. So firstly, it's shown like begin by opening the Windows command prompt and enter the command ipconfig/release, right? So this is for the Windows, and for the Mac you have to uh, write this command sudo ipconfig set the interpreter, like set the interface to the none. So it just shows like, see, for example, interface name. For example, if you just don't know what you should do in the place of see, for me, the uh, wait a second. um, in order to know the interface name, just type ifconfig, yeah, and over here at the ending you get the similar thing. If for example, for me it's on en7. If you guys have it on en0, en1, en2, just replace the en7 with en2. Okay, so now as of now I am using the interface name as en7, and now again I'll just enter the command to sudo ipconfig, which is set to en7, and I'll be just clearing the IP address of it, which is as a password. Enter it. Okay, now done. What you have to do is open the Wireshark in parallel, and again just open it. Now stop it. Again start it. Okay, now in parallel, I have run the previous command, right? So run it again to none, and it has been set to 0. And again what you have to do is in the second step, and go back to terminal and again enter the ipconfig/renew. So ipconfig/renew is for the Windows. So for Macs, you must use a sudo ipconfig, which is set to the interface name of your network, and enter the DHCP here. So after entering it, copying it, pasting, enter it, it has been set to the DHCP. Okay, so now that command means that a new IP address, like the host obtains its original IP address. So once that has been completed, again enter the same command. Okay, I have entered the same command. Okay, now what you have to do is when the second ipconfig/renew terminates, enter the command ip/release to release the previously allocated previous IP address to your computer. So again, just clear it up to none. Okay, so I'm clearing it up to none, and finally I'm entering again the ip/renew. So instead of that, I'll be just entering the DHCP. Okay, now everything is completed. So now stop the Wireshark packet capturing. Okay, and now we'll just answer the questions. Okay, now in the filter one, in the filter, just filter it with BOOTP. Okay, so if you filter it with BOOTP, UDP and enter it. You get these following packets, and now we'll just answer the questions regarding those packets. So first question is, are the DHCP messages sent over the UDP or TCP? See, for that, see over here, the first one is running on the UDP protocol, and the second one, third one, fourth, five, six, and like not only one, everything is been running on the same UDP protocol. So the answer is they are running over the UDP protocol. So second question, draw timing datagram illustrating the sequence of the first four packets discover of a request and the ACK DCP exchange between the client and the server. For each packet indicated some source and the destination port numbers. Are the port numbers same in as given in this lab assignment? Yeah, for that in the lab assignment, yeah. Wait a minute. Yeah, for that open the Wireshark, and in the statistics use the flow graph thing. Okay, over here you can see the port numbers over here. So for example, if I just select this thing, okay, now I'm just selecting this particular thing and just statistics, and again doing the flow graph of particular thing. Okay, over here the port numbers are same, right? See, whatever the sites which we have got, and see over here we can see the port numbers are same. Okay, so the port numbers are same, and yeah, and the next question, what's the link layer address of your host? So the link layer of the address of the host can be seen from here. Okay, so this particular thing, right, source path 70 slash hyphen 01 hyphen b5 hyphen a5 hyphen d1 hyphen f7, this is the link layer address of my workstation. Okay, so next question, what values in the DHCP discover message differentiate this message from the DHCP request message? Okay, what is the thing that differs from the DHCP discover to the DHCP request? Okay, DHCP discover, over here in the DHCP discover and in the DHCP request, the thing which have been differentiating, see for example over here, if we just see this, there are multiple things which are present in the dynamic host control protocol, and there are several header files. Okay, you can see, and similarly for this almost everything is been same. Okay, even including the source address and the destination address and the port and the destination port, everything has been same. Okay, so the only thing which is been different is the message of it. Okay, so here the message for the DHCP request is the DHCP message types in brackets of request. So for the discover, it is a DHCP message type slash discover. So the only thing which difference is the option 53 DHCP message type. Okay, so next question, fifth question, so what's the value of transaction ID in the first four DHCP messages? Okay, the first four DHCP message transaction ID values. See, for the first thing, DHCP discover, wait a second, discover offer request and Discover, offer, request, and ACK, right? Discover, offer, request, and ACK. So in the discover, the transaction ID is 0x26A3494E, and in the DHCP offer, the transaction ID is 0x26A3494E, which is same as it, and which is same as it again, and which is same as it again. Okay, so they are same. And what are the values of the transaction ID in the second set of request ACK for the DHCP messages? So again, in the second row, request and ACK. Okay, uh, here the request transaction ID value is 0x623A15B9, and here also 0x623A15B9. Okay, so the both are also same again. So what we can do over here is that just answer it like they both are same, and what's the purpose of the transaction ID field. Okay, the a transaction ID is always used so that the DHCP server can differentiate between the client request during the request process. Okay, so next question: a host uses the DHCP to obtain the IP address among the things, but a host IP address is not confirmed until the end of four messages. Its IP address is not sent out. Then what values are used in the IP datagrams in the four messages exchanged? See, okay, over here the source path. See, for example, in the first four, in the discover, uh, offer, request, ACK, the source, I mean like the client source address is same as 0.0.0.011, and the host IP address is 172.16.16.1. And over here in the destination port, it is similarly same as 255.255.255.255, and for the client also it varies from point to point. Okay, so the DHCP client and the server both use 255 point 255.255.255 as a address for the specific two things, and for these both the specific two things, specific to address. Okay, so while the client uses the source IP address as 0.0.0.0, and while the server uses it as the actual IP address from the source. So next question: what's the IP address of your DHCP server? See, the DHCP server of the IP address of my DHCP server is 172.16.16.1. And next question, 8 question. What's the IP address? What IP address is a DHCP server offering to your host in the TCP offer message? Indicate which DHCP message contains a offered DHCP address. So over here in the DHCP offer, the client address of my website is 172.16.16.63, and the offer message is like the DHCP message. It's in a type of offer. Okay, so next question in the example, uh, is there a relay agent between the host and the DHCP server, and what value in the trace indicates the absence of a relay agent? Is there a relay agent in your experiment? So for that, just go to the ACK of the DHCP, and over here there is a option like relay agent. See over here there is a relay agent IP address for me, and Yeah, the relay agent IP address is 172.16.16.1, which indicates that there is a DHCP relay used, and there was no relay agent used in the experiment. Okay, so 10th question: explain the purpose of the router and the subnet mask lines in the DHCP offer message. In the DHCP offer message, there is subnet mask and the router. Yeah, subnet mask and the router message. So the router line indicates that the client what its default gateway should be, and the subnet mask tells to client that which subnet mask it should use. Okay, and next question: in the DHCP traced file, the DHCP server offers a specific IP address to the client. In the client's response to the DHCP first server offer message, does the client accept this IP address? Wherein the client's response to the client's response address. So over here, in open the Wireshark and go to the DHCP request message. So over here, the requested IP address is 172.16.16.63. Okay. Next question: explain the purpose of a lease time and how long is a lease time in your experiment. Uh, yeah, in this lease time can be found in the acknowledgement packet, and in the acknowledgement packet there is a lease time called we hit this thing, and it took the lease time of mine is 15 days, and generally what lease time is that it's an amount of time in the DCP that the server assigns a new IP address to a client. During the lease time, the DHCP server will not assign the IP given to the client to another client unless it's released by the client. Once the lease time has expired, the IP address can be reused by the DHCP server to give another client. So in my case, the lease time is 15 days. Okay. So next question: what's the purpose of DHCP release message, and does the DHCP server issue an acknowledgement of reliability of the client's DHCP request? See, yeah, the client, in my case, the client sends a DHCP release message to cancel its lease on the IP address given it by the DHCP server, and the DHCP server doesn't send the message back to client uh, acknowledging that it's a DHCP release message. If the DHCP release message from the client is lost, then the server would have to wait until the lease period is over for that IP address until it could be reused for another client. Okay, so final question: clear the boot TP filter from your Wireshark window. Were there any ARP packets sent or received during the DHCP packet exchange? If so, explain the purpose of those ARP packets. So here just I filtered and unfiltered the boot TP, and now yeah, there are ARP packets over here. So ARP packets are generally the requests that are made by the DHCP server. So before offering an IP address to a client, the DHCP server issues an ARP request for the offered IP address, and to make sure that the IP address is not already in use by another uh, station, let's say. See, yeah, for example, let's say over here the address resolution protocol. Here the targeted IP address is 172.16.16.1. Okay, so yeah, thank you.